It's a debugger. And we've already seen debuggers a little bit. So I've already shown you pythontutor.com, and you've also seen us use the debugger in the Thonny editor right here. Now, in the starting code, we have a function called mutate that takes a list as the input and then prints another list at the end. So what happens is we start out with this B list being an empty list, and we have a new item that starts out being 0. Then we loop through each of the items in the A list that comes in through the input, and we multiply it by 2 and turn that into the new item. And then we modify the new item even further by adding to it a random number between 1 and 3. Finally, we use a function called add in our maths module, which we created right here, and it does the simple thing that you created before, which is just to add one number to another. So we add the new item that we've got up to now to the item that we're currently looping through, and finally we add it all to our B list, and hopefully we are able to modify the A list with this step-by-step approach to end up with a new list where each of the numbers is modified according to our rules. Now, unfortunately, at the moment, it does not do what we expect it to do. It just prints out a single number in a list. So in order to debug and figure out what is wrong with our code to be able to fix it, we're going to cover how to use the debugger in PyCharm. Now, debuggers are pretty similar in most of these intelligent development environments, such as PyCharm. So I'm going to use this opportunity to show you a lot of things that will be reusable even if later on down the line you choose to use a different code editor. Now, what we do first is we can define what's called a breakpoint. So a breakpoint can be created in the gutter of our code, and you might have done it accidentally before. So when I hover over these line numbers in the gutter, you can see this red dot appears. And if I decide to go onto line 9 and click on that red dot, I've now created a breakpoint. And you can see that breaking line is now highlighted. So now I'm going to go into the debug run mode by clicking on this little bug here, and it's going to run my current file, and it's going to take into account the fact that now I have a defined breakpoint. So what does a breakpoint do? Well, it basically puts a break on the code at that particular line. So here is where I'm setting the new item from 0 to a new value, which is the value of the item multiplied by 2. Now, you'll see a couple of things show up already in line in our code, which is kind of helpful. It's showing us at this point where the code is at, where we've stopped the code on line 9. The current value of a list is this big list, which we inputted right here. So this is the input for this function, and that's showing up right there. And then it's showing us B list is still an empty list, new item is 0, and item, which is the first item in the A list that we're looping through right here, is equal to 1. So now what we can do is use the first of the step buttons in the debug console. So if I click on this one, which is called step over, what it's going to do is it's going to execute my code line by line, stopping at the very next line. So now that we've executed this line, which we've broken, it's now happened, and we can see that what's updated is the new item is no longer equal to 0, but it's now equal to 2, because we took the item, which is 1, multiplied it by 2, and then set it equal to new item. So new item is now equal to 2 instead of 0. So we can continue stepping over to the next line, and remember that the highlighted line is the one that's going to be executed next, and the line above it is the one that just got executed. So right now we can see that this line 10 has just been executed, and we've generated a random integer between 1 and 3, and we've added that number to our new item. So now our new item is equal to 5. So while we're here, we can do something else. We can look at another one of these buttons. So if I go ahead and rerun my debugger, and I use, instead of the step over button, I click on the step into button. So it's going to continue executing each line as it goes, line by line. But when it encounters a line such as line 10, where we're using another module, so code in another file, such as this randint function from the random module, when I click step into, it's going to go into the definition of that function, the randint function, in the random module from random.py, which is built into Python. And it's going to show you how that function works. So in fact, randint actually uses another function called randrange. And if I continue stepping into it, it will go and find this function randrange and show me how that function works. Now, once you're done exploring this, which can be really helpful because your code relies on code that's been written by other people, and if you want to know how they've defined it, how they've created randrange, then you can read through their code, and sometimes it can provide helpful hints for us to figure out what is wrong with our code. Now, you don't want to continue stepping through other people's code, so when you want to exit, you click on this button, which is step out. And we can continue stepping out until we get back to the code that we want to examine. So this can be really helpful where we're stepping through the functions, but more often than not, we don't actually want to step into the library functions such as random, because they work the way they do and we can't really modify it, so we probably haven't made a mistake there. And what we want to do sometimes though is we want to be able to step into code that is in other files, but only the code that is written by us. And we want to ignore these library functions written by the Python team. So how can we do that? Well, let's repeat from the beginning. So this button restarts our debug run and again pauses on our breakpoint. Instead of using this step into button, we're going to use the step into my code button, which does exactly the same thing as step into, going line by line, but it ignores the library functions. For example, that random function right there. It doesn't take you over to the random.py file. But now, if I click into step into this current line 11, then it takes me into this file that I created, math.py, where I created this function called add. And it shows me that right now I'm trying to add 4 to 2, which was passed over from the previous function call. And if I step out of that add function in the math module, I can go back to examine my file. So this button can be more useful when we have multi-file projects and we're trying to examine the cause and the relationship of what could be going wrong in our code. Because very often, as our code gets more and more complex, there's more and more relations that start happening, and we're sometimes using code that's been defined elsewhere, and chasing it around can be quite difficult. So those are some of the most important features of the debugger, and I want you to take a look also down here. We've got two tabs here, the threads and variables and the console. So the threads and variables can be really helpful, showing us the values of the variables that we've got going on. So for example, just as they've shown up here as these comments, you can also see them in the list right here. What's the current value of new item at this particular time point? What is the current value of B-list at this particular time point? And as you can see that as I continue stepping through my code line by line, these values, they update as they get changed in the code. So we can actually trace what's happening to each of our variables in their intermediate stages. And especially for something like a for loop where everything is pretty much hidden, we don't know what's going on while it's looping, this can be really, really helpful to help us figure out what's wrong with our code. So the other tab here is the console, and you can see that it shows what gets printed during the run of the code. So for example, if I was to get rid of this breakpoint, so I can either disable it by clicking it once and it goes into this darker color, or I can keep it there and simply say mute breakpoints. Now, if we continue running through our code and stepping it through, you'll see that eventually it ends the loop and goes to the print, and we can see that print happening in the console. So we get our console even when we're running in debug mode as well. So that's pretty much all there is to it, to the major features of a debugger. The most useful thing, I think, is just simply being able to see these values show up as you go through the code, stepping through each of the lines. So now it's your turn to use what you've learned about the PyCharm debugger and figure out what is wrong with our code. Why is it not printing out an entire list with 1, 2, 3, 4, 5, 6 items, and instead why is it only modifying and printing out the first item in the list? So pause the video and complete this challenge. Alright, so with our breakpoint in its current position, let's do another debug run. And we are going to watch the value of the B list and see if it's changing the way we expect it to. So as I step over each of these lines and we're looping through the list, one thing you'll notice is that the value of B list is not changing at all. So at which point does it actually get populated with these new items? Well, it's on line 12. So let's disable this and put our breakpoint here instead. Let's go ahead and resume our program until it runs to this point, and we can see that B list is still empty, and all that's happening is we're appending new item. So new item is currently equal to 42, as we can see here, and if I step over this line to execute it, you can see that 42 gets added to the B list, and then if I step over once more, you'll see that print statement execute and that 42 gets printed. And then that's the end of our code. So what's happening is that these new items are not being added to the B list as they're created. So the only thing we need to do is just to add an indent. And so often my Python code fails because of an indent or because of something silly like that. But with the debugger, it makes it a lot easier to figure out what is the problem. So if we do another debug run and you watch how this B list changes now, every time we loop through B list, once we get to the end of it, that new item gets added to the B list. And you can see it adding a new item each time the loop runs. And that is what we expect to happen.